Hi, my name is Jacob Tommy, and this is Lab 3. This lab sets out to find an expression for a magnetic field generated by a magnetic dipole at an observation location using the experimental data collected by the magnetometer sensor in a phone. Additionally, this lab tasked us with writing a program to calculate the magnetic field at any observation location based on our results from this experiment. There are four main sections to this lab. One, locating the exact position of the magnetometer sensor in our phone. Two, measuring the magnetic field using the sensor at different distances. Three, analyzing the data using an Excel spreadsheet to find the expression. And four, write a program to find the magnetic field at any observation location in space. Finding the location of the magnetometer first required the phone to be aligned with the magnetic North Pole in order to prevent the Earth's magnetic field from contaminating the measurements. Then I moved the bar magnet along the length of the phone to find the x-coordinate of the sensor, and did likewise along the width of the phone to isolate the y-coordinate of the sensor. Then I found what distance from the sensor created a magnetic field of magnitude 1000 microtesla, and then measured the magnetic field at three more distances further away from the sensor. The graph on the right plots the natural log of the data I collected in order to linearize the data. The equation that is graphed corresponds to the equation ln b equals ln k plus n ln r. This means that the slope of the graph equals our value for n, and the value of k can be found from the y-intercept by raising e to the power of the intercept. Our result is the equation b equals 9.75 times 10 to the negative 8th times r to the negative 2.85. I used the data that I found experimentally to solve for mu of the magnet. Using the equation b equals 2 mu over r cubed, I was able to use the different distance values and their corresponding magnetic fields from the data I collected to find an average value of mu for the magnet I used. I found mu to equal 0.332, and I used this value in the code. Comparing my results to the experimental formula, my value for n, negative 2.85, was close but still had an error of 5%. My value for k was close with an error of 2.5%. However, my results for the magnetic field at an observation location of 45 degrees from the horizontal generated by my code differed greatly from the values I acquired experimentally. I think that the app I was using was at fault, and I expected the computer calculations were more accurate, although the distance I used, 0.1 meters, may have been too small a value for the model to compute accurately.